in special relativity, there's the action of space-time on matter, but there's no direct back reaction of matter on the space-time continuum. There's a geometrical structure. And when he put that in, that's solved. That's, gravity is the curvature of space-time in general relativity. And so by using this idea, general idea, you can never have action without reaction. He got general relativity, he explained gravity, all black holes, everything, cosmology. I mean, one of the greatest discoveries of all time. Now, the same thing's happening today. Same idea. This is sort of my original research, but I'm just standing on the shoulders of Einstein here. I mean, Einstein had a good idea, action, reaction. Now, it turns out quantum theory has a very similar, it's like special relativity. Quantum theory has this quantum information field, the wave functions, all that stuff, which Sir James Jeans compares to the great thought. In fact, even Niels Bohr, the original fathers of quantum mechanics, were very aware that the quantum wave function is kind of mental, and it's like a mind thing, a mental thing, intrinsically mental. Okay, but what happens is all the things about Bell's theorem. If you read how the hippies say physics, it goes into this in great detail. Although there's this spooky, in quantum entanglement, there's this spooky kind of telepathic, Einstein called it spooky telepathic action at a distance, okay? And which seems to violate special relativity. He didn't like it. But what happens is, even though there is this quantum entanglement, which is kind of like a spooky voodoo-like telepathic action at a distance, nevertheless, there's like a catch-22. You cannot use it to communicate a message. In other words, I cannot send you a message using quantum entanglement alone where you'll get the message. You can do it, but only if you have a secondary classical signal. It's like a cryptography. You need a key to unlock the secret message. Okay, and in fact, there is now, there's a lot of practical stuff. The whole quantum revolution, quantum cryptography. There are secure ways of transmitting financial information, military information. I mean, this is a big thing. This is what we created. This is the point of his book, because me and my crazy friends, we were talking about this kind of stuff back in the 70s when all the mainstream physicists would say, oh, it can't happen. But now they actually are practical, back to your question, there are practical quantum cryptographic devices. However, they're supposed to be unbreakable. However, the thing is this, the problem with that kind of conventional quantum theory, and it works in a certain, physics theories work in a certain limited domain of phenomena, but there's always something else beyond that, okay? The ordinary quantum ideas that are being used in practical quantum cryptographic systems today, that are being used in banks and more in military communications, command control communication systems that are untappable, but they also have that the mental thought field, the quantum field of information is causing matter to jiggle, to move, okay? But there's no direct back reaction, again, of the matter on its mental field. David Bohm called it the pilot field. It's like this mental field, this quantum information field pilots. It affects the motion of matter in addition to ordinary forces, in addition to electrical forces. There's this other, but there's no direct back reaction of matter on its own pilot field. The idea is just as gravity was the direct back reaction of matter on the space-time geometry, so it is that consciousness, direct experiences, is the direct back reaction of matter on its quantum pilot field, which is like a minefield. It's like the quantum waves, quantum information fields are sort of like the subconscious mind, okay? But in order to have an experience, in order to feel something, who we are, our souls, whatever you want to call it, the things are happening in the real world, in the material world, electrical signals. Somehow they get to a certain point in our brain, and we've seen there's a guy named Stuart Hameroff who talks about microtubules in the nervous system. These are like nanoscale. It's like nanotechnology, like biological nanotechnology. We actually have structures that, in fact, there's single electrons They're like electron switches that we carry in the substructure of our neurons. And it's these things, those electrons acting on their own quantum mental fields are maybe generating our conscious experiences. But now here's the thing. If this general way of looking at things, which basically Einstein, action-reaction, it's a battle-tested idea. It's not a difficult idea, really. If that's true, what does that mean? That means we can test it. Any good scientist, because in principle, like Star Trek, Commander Data, was he conscious? Back to Alan Turing, the Imitation Game. Can we make artificial intelligences that have our kind of consciousness? And I think the answer is yes. In fact, I think we're getting pretty close to that, getting very close to that, because we've now. If you read about Stuart Hameroff at University of Arizona Tucson, if you look at the microtubule structure of our nerve cells, you'll see it looks like a computer. It looks like a nanoscale. We're talking about millionths of a meter. It's like a very tiny computer system. And in fact, even now at Silicon Valley, they're getting down to that level. They're developing quantum computers. We're getting there. So the point is, all we have to do is just. If you look at us with an electron microscope and our nervous systems at that level, it looks like a computer system of molecules, biological molecules. But if we could do that in silicon, we can do this. Consciousness is universal. It's not just we're not wedded to our particular carbon-based system. We can do it, make artificial life, with consciousness. Yeah.
Do you personally think that all this stuff happened by chance?
No. Well, okay, well now, if it's coming from the future, if this future horizon is a giant computer, it's Hawking's mind of God, perhaps. It's an advanced intelligence.
But what do you think?
Well, what I think, I've had you read my book Destiny Matrix, this biography, and then you see what I mean. A lot of strange things have been happening. It looks like, okay, there's this guy Nick Bostrom at Oxford, and he's just written a book on advanced superintelligence, and he deals with all these questions that we're talking about. And I suggest take a look at that book. In fact, I.J. Good. Does everybody know about Bletchley Park? With Turing and everything. Okay, I.J. Good worked with Turing at Bletchley Park, and then after the war, he started thinking along these lines. He calls it God, G-O-D, with another D in there, and it's a kind of cosmic superintelligence. He was into that. Fred Hoyle, I don't know if you heard, Fred Hoyle wrote a book in the 1980s called The Intelligent Universe. He's talking about all these ideas that there's this cosmic intelligence, but that was before the discovery of dark energy. They were just like being intuitional. Now we actually have a structure, this future horizon, which is like the surface. Okay, black hole surfaces, the event horizon black hole is also like a computer. Okay, but we're outside black holes. But it's like we're inside this the cosmic horizon. It's like we're sort of inside. It's not a black hole, but we're inside this cosmic horizon, this surface, which is a computer. It's a computer, by the way, that's worth about 123 powers of 10 of quantum bits. Okay, and now a quantum bit of information is almost like an infinity of classical bits in a classical computer. So we're talking about a huge computational thing. And the question is this thing is conscious also, because this back reaction I was talking about, the simple idea, if that's true, then it's a conscious, it's the mind, it's God. It's God, right? What else are you going to call it, right? So the point is, let me just summarize. And then maybe take another question too. The point is there are things happening in general relativity theory, Einstein's theory, and in quantum mechanics, which are giving us detailed cosmological structures which look like computers. And the issue is, are they conscious computers? And it looks like it may be a superintelligence. And also on our own level, when we use electron microscopes and we're getting into nanotechnology, our own bodies, it looks like, we could be artificial. We could be created by something, you know. I mean, we're carbon molecules, but you know, that's just, I mean, molecules, and it's all chemistry, and it's like machinery. You look, I mean, okay, Hammeroff, this guy, biologist at the University of Arizona in Tucson, he took an electron microscope picture of the microtubule structure in a single neuron, and he gave it to a computer engineer at Intel, and he said, "Oh, what kind of chip is that?" The computer guy said, "Then he didn't tell him what it was. What kind of chip is that?" Okay, so you know, what's on the horizon is you know, it's like Blade Runner. Did you see Blade Runner? The movie Blade Runner. You know, and I mean that we, you know, well, there's another thing: immortality, practical immortality. You know, did you saw the movie Transcendence? You know, is it Tom Cruise? Who was it?
Johnny Depp.
Johnny Depp, yeah, Johnny Depp. Well, that kind of thing. Well, there's this guy in Silicon Valley, you know, the singularity guy, Ray Kurzweil, and there are a lot of people. The transhumanist movement. The point is, if we understand consciousness, and I think I have a pretty simple physical picture of what consciousness is in terms of basic physics. Action, reaction, using Einstein's ideas, pictures, you know, it's a universal thing, okay? And we can imagine making conscious computer chips. We can imagine building robots, you know, with consciousness, and we can imagine, when you're dying, uploading your own consciousness into this thing. Or you can even imagine making a clone of yourself, because the clones will deteriorate, because, like, you know, as you keep making clones, you can imagine uploading your memories and your experiences into a computer system, then they clone from your own DNA, and you're downloaded into a younger version of yourself. Michio Kaku has a book called The Future of the Mind. He's a top physicist in New York, and he has all this kind of, and this is not only thinkable, it's probably going to happen. There's a good chance it's going to happen. And it's going to totally change, well, look how the internet has changed things in 20, 30 years. I mean, you ain't seen nothing yet.
Yes.
Yeah.
I've been struggling with this past, present, and future, and I was trying to get back to that point where you said it was going to get simpler. But basically, what you did say that the thing that you said that hit me as, sorry, I thought I'm not a scientist,
no, that's all right.
but you know, was that something was travelling faster than light.
Okay, well,
Has this, you know, can this be?
No, but here's the thing about what relativity says. Relativity says that an ordinary particle moving through the space-time continuum, that can't go faster than light. But space itself can. See, special relativity only talks about particles moving within the continuum, not the stretching, not the expansion of the continuum itself, the space-like part of the continuum itself. In fact, that's the whole theory of what's called inflationary cosmology. So he starts with this idea that it's that the three-dimensional spatial part of the space-time continuum, that can expand at any rate at all. It's just stuff going in it. In fact, in cosmology, the particles moving through the expanding space, that's called the peculiar velocity. The peculiar velocity, say, of a galaxy, that cannot be faster than light, but the expansion rate itself can be. But when it is faster than light, you get this horizon effect. We can't see beyond that using light signals. But you have horizons from the future and horizons in the past. It's tricky. It's hard to grasp with one thing.
Jack, one last one.
It seems to me, I think that possibly Aristotle final cause is not final in the sense of future, but final in the sense of the sort of undergirding ontological, the basis of all things.
Yeah.
It's not about. I'm sorry, obviously it's not what you think either, but it's not about everything only making sense if one looks from the future back. One could easily set up an overall pattern where saying it only makes sense if you actually understand that which undergirds, or indeed perhaps it's all about the eternal now, and that the present is. I mean, I'm just so delighted that your physics is rooted entirely in metaphysics, which seems to me absolutely correct. and proper. But the final cause isn't about a cause which will only become clear at the end of time.
Oh, no, it's become,
a cause.
yes, I
It's
agree.
final in the sense of ultimate and therefore metaphysically.
Yes, if it would only become clear at the end of time, it's not much use to us, right?